Imagine standing on a cliff, feeling the invisible hand of gravity tugging you downward. But what if that pull is an illusion, a cosmic deception hiding a deeper truth? For centuries we believed Sir Isaac Newton's tale, gravity as a force, pulling objects together like an unseen magnet across the void. It explained falling apples, orbiting planets, even tides. Simple, elegant. But cracks appeared, mysteries Newton couldn't solve, lurking in the stars. Enter Albert Einstein in 1915, wrestling with light, speed, and the fabric of reality. His general relativity whispered, "Gravity isn't a force at all." Instead, massive objects curve space-time itself, like a heavy ball sinking into a trampoline, guiding paths without pulling. But it was Richard Feynman, the charismatic genius, who made this mind-bender accessible. In his legendary lectures, he dismantled the pull myth. Feynman asked, why assume gravity pulls? What if paths are straight in a bent world? A revelation that shatters our intuitive physics. Picture an ant on a crumpled paper. It walks straight, but the terrain twists its journey. That's us in gravity's grip, curved, not pulled. This flips everything. No mysterious force yanking distant galaxies, just geometry dictating fate. Suspense builds. What does it mean for us? Feynman's words echo. Nature's imagination is so much greater than man's. Prepare for the shatter. Physics as we know it crumbles. We descend deeper into Feynman's world. In his Caltech lectures he challenged us. Imagine no force, only curved geometry guiding everything. He said objects fall because space-time bends around mass. Straight lines in curved space become orbits, falls, spirals, pure geometry, no pull required. Consider the equivalence principle, Einstein's happiest thought. Acceleration and gravity feel identical. In a sealed elevator, you can't tell falling from floating. Feynman loved this. A rocket accelerating upward feels like gravity. No difference locally, so gravity isn't a force. It's the shape of space-time. This demolishes Newton's action at a distance. No spooky instantaneous pull across empty space, just local curvature telling matter how to move. But Feynman went further. He asked why we feel weight. Standing on Earth, the ground pushes up, resisting your straight path inward. In freefall, you'd follow the curve naturally, no weight. That's why astronauts float. The floor isn't there to deflect your geodesic. Feynman's clarity hits hard. Gravity doesn't pull you down. The ground pushes you up, away from the straightest possible path through space-time. This revelation reshapes reality. Black holes become regions where curvature is so extreme, not even light follows a straight enough path to escape. Gravitational waves, ripples in space-time, carry news of cosmic collisions. Detected in 2015, they confirmed Einstein, and Feynman's geometric vision triumphed. Everyday proof stares from your phone. GPS satellites orbit higher, experiencing weaker gravity and faster time. Relativity corrections keep locations precise. Without Einstein's curvature and Feynman's insights, your maps would drift miles daily. Geometry, not force, guides signals through bent space-time. Light itself bends. During 1919 eclipse, stars shifted position near Sun, proof massive objects curve paths, confirming no pull needed. Mercury's quirky orbit perplexed Newton. Closest to Sun, its path precessed oddly, until curvature explained the geometric drift perfectly. Feynman wrestled gravity's deepest mystery, uniting it with quantum rules. Classical curvature clashes with probabilistic particles, nature's greatest puzzle. String theory, loop quantum gravity, modern heirs chase Feynman's dream. Tiny vibrating strings or spun space-time loops might reconcile everything. Wormholes emerge naturally in extreme curvature, theoretical tunnels through space-time, shortcuts that bend reality, perhaps enabling time's impossible loops. Big Bang itself, a singularity where curvature goes infinite. All matter, space, time born from geometric extreme Feynman helped us grasp. Black hole interiors hide ultimate truth. Information paradox challenges. Does curvature swallow data forever, or does quantum rescue it? Feynman's answer endures. Gravity doesn't pull. Space-time curves and matter simply follows. A poetic geometry governing cosmic destiny. Yet questions linger. If gravity is pure geometry, why does it resist quantization? Feynman's path integrals falter where curves meet quanta. Renormalization saves other forces, but gravity rebels. Infinite terms cascade. Feynman's tricks fail against the infinite curvature of the very small. Asymptotic safety, emergent gravity. Bold ideas chase unification. Perhaps spacetime itself arises from quantum entanglement, geometry born from information. Dark energy accelerates expansion, not a force pushing, but negative curvature stretching the fabric, driving galaxies apart in silent geometric decree. Feynman's spirit lives in every probe. Gravitational wave detectors listen for spacetime's whispers, decoding mergers that Newton could never dream. James Webb peers deeper, seeing infant galaxies shaped by curvature's gentle hand. No mysterious pull, just paths written at the dawn of time. We stand on a pale blue dot, feeling weight, because Earth blocks our inertial plunge. Feynman's truth liberates, gravity as freedom's subtle cage. This vision humbles and exalts us. No supernatural tugs govern fate, just elegant mathematics painting orbits, falls, the dance of everything. Feynman's gift was clarity amid complexity. He stripped gravity's mystery, revealing not a force, but the universe's deepest geometric poetry. So why does gravity not pull? Because nothing pulls. We move straight through a curved cosmos, and that simple truth shatters physics forever. The apple doesn't fall because it's pulled. It follows the straightest path available in space-time curved by Earth's mass, an inertial journey deflected by ground. Feynman's lectures still resonate. He urged us to abandon old intuitions, embrace the geometry that unifies the immense and the intimate. This understanding transforms fear into wonder. Freefall isn't falling, it's the purest motion, the path nature intends when nothing stands in the way. From orbital stations to planetary probes, engineers now calculate trajectories using curved geometry. Feynman's legacy guiding humanity's reach into the stars. Even time bends. Clocks run slower deeper in gravity wells, proven by atomic clocks on planes, mountains, satellites, geometry dictating the pace of existence. Feynman reminded us, the universe isn't strange, we are. Our senses evolved for flat Earth survival, not cosmic curves and relativistic truths. Yet beauty emerges in the difficulty. The same curvature that confounds us paints rainbows in gravitational lensing, reveals hidden galaxies behind clusters. We are children of curved spacetime. Every step resists Earth's attempt to follow the sun's indentation, our weight, the price of standing still. Feynman's final message rings clear. Seek not why things pull, but why paths bend. In that question lies the universe's most profound elegance. Gravity doesn't pull, it shapes the stage on which everything dances. Feynman's answer didn't shatter physics, it revealed its true breathtaking harmony. Tonight, gaze upward. Stars don't hang by invisible threads, they trace ancient geodesics etched by the universe's gentle, relentless curvature. Feynman's voice lingers across decades. Question everything, especially the obvious. Gravity's pull was obvious, until geometry unveiled the profound illusion. Children drop balls, intuitively expecting force, but teach them curvature young. Perhaps future minds will grasp relativity as naturally as walking. Art and science converge here. Curved spacetime inspires sculptures, paintings, symphonies, beauty born from the mathematics of reality itself. Every black hole merger sings gravitational songs across the void. LIGO hears them, ripples carrying Feynman's geometric truth through billions of years. We are spacetime travelers. Our world lines weave through curvature, from birth to end, free yet guided by the cosmos's invisible architecture. Feynman's legacy isn't equations alone. It's joy. Joy in discovery, in shattering illusions, in seeing the universe's imagination surpass our own. So embrace the shatter. Let old intuitions fracture. What remains is purer, deeper, a universe not of forces, but of elegant paths. The question echoes eternally. Why does gravity seem to pull? Because we stand in its way, deflecting our natural straight descent through time. Feynman's answer liberates us. No chains of force bind the stars, just freedom to follow the universe's curved, magnificent roadmap. In this geometric cosmos, every orbit is a promise kept. Planets whisper to stars along curved paths, eternal without need for pulling hands. Feynman's curiosity infects us still. He taught that understanding deepens wonder. Gravity's true nature amplifies the universe's majestic, impersonal beauty. No longer prisoners of intuition, we soar intellectually. Curvature frees us to see reality's fabric, woven from mathematics more profound than force. The shatter heals into clarity. What broke was illusion. Emerging truth unites Newton and Einstein in geometry's grand, encompassing embrace. Future explorations await. Warp drives, if possible, would ride these curves, contracting space ahead, expanding behind, without ever exceeding light. Feynman's analogies endure because truth resonates. The trampoline, the ant, the elevator, simple portals to profound geometric insight. We feel small, yet connected. Every atom in our bodies follows the same rules that guide galaxies, curvature's universal democratic law. Dark matter hints at deeper curvature, invisible mass bending light, shaping galaxies, geometry's unseen architects working silently across eons. The universe expands, curves evolve. Feynman's vision prepares us for whatever final theory emerges, geometry likely at its heart. Thank you, Richard Feynman. Your clarity pierced centuries of myth, gifting us a cosmos more wondrous because it's curved, not pulled. As we stand here today, Feynman's revelation reshapes how we teach, explore, dream. Gravity as geometry invites everyone into the cosmic conversation. No longer distant mystery, gravity becomes intimate truth. The curve beneath your feet connects you directly to the farthest quasar's ancient light. Feynman's playful spirit reminds us, science isn't solemn, it's delight. Discovering gravity doesn't pull fills hearts with childlike cosmic joy. This truth empowers. Engineers bend orbits with precision, knowing paths are guided by curvature. Humanity's spacecraft dance along nature's geodesics. Even philosophy shifts. Free will, destiny, perhaps illusions too. We follow world lines through curved time, choices branching along possible geometries. The universe whispers consistency. Same curvature rules govern falling raindrops and merging neutron stars. Elegant unity Feynman celebrated with wonder. Feynman's lectures echo eternally because they humanize genius. Complex ideas delivered with humility, making space-time curvature feel like common sense. We inherit this gift. Every time we explain gravity without pull, we honor Feynman's mission, replacing myth with clearer, deeper reality. The final shatter reveals harmony. Physics wasn't broken, it was incomplete. Curvature completes the picture, painting existence with breathtaking precision. So remember, gravity doesn't pull. You glide along spacetime's gentle curves, a passenger in the universe's most elegant, unending journey. This geometric truth carries hope. Understanding curvature equips humanity to navigate stars, harness energy, perhaps one day reshape space-time itself. Feynman's wonder was contagious. He showed that asking why pull leads to deeper questions, igniting curiosity across generations. In quiet moments, feel the curve. Your weight is Earth's gentle deflection of your timeless path through four-dimensional reality. The universe needs no invisible strings. Curvature alone orchestrates everything, from subatomic dances to galactic superclusters, in perfect silent harmony. Feynman's gift endures because it simplifies without diminishing. Gravity as geometry makes the cosmos feel both intimate and infinite. We are not falling, we are following. Every step, every breath aligns with the same geometry that guides light across billions of years. The illusion of pull dissolves into freedom. Nothing yanks us down. Space-time's curve simply is, and we move through it naturally. Feynman's answer completes the circle. From Newton's apple to Einstein's cosmos, geometry reveals the universe's deepest, most elegant secret. Tonight, look up. Those stars shine along paths curved by mass long gone, messages traveling straight through a bent universe. Gravity doesn't pull, it curves. And in that simple, profound truth, Richard Feynman's revelation forever changed how we see everything.